My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 209. In this lecture, we will try to understand dot product and angle between two vectors. So, imagine if you are given two vectors A and B. Let me assume A is one vector and B is another vector. Both of them are row vectors. Let me assume my A vector is having components A1, A2, so on An. As I told you, it is row vector. In similar manner, my B vector has got components B1, B2, so on, let me say Bn. Now, mathematically, let's learn some very basic operations. What about addition of vector A and vector B? It's simple. It's a component wise addition. A bar plus B bar means I must add the components A1 plus B1 comma A2 plus B2 so on An plus Bn. It's simply component wise addition. It is very straightforward idea. This is how you add two vectors. Very simple idea. This addition of vectors, this is the addition of vectors. The immediate question that comes to your mind, what about multiplication of two vectors? There are two types of multiplications. First one is known as dot product, and second one is cross product. So just for simplicity, we don't use cross product. Let me repeat. So just for simplicity, we don't use cross product much in machine learning. So I will not go into the details of what a cross product is, but let's go and understand what a dot product is. So if I am given two vectors A bar and B bar, a dot product is written as A bar dot B bar. I can say like this. It's written as A bar dot B bar. First I will explain the notation, then we will go and understand geometry behind this dot product. A dot B is nothing but what it is. A bar, if your A bar is A1, A2, An, your B bar is B1, B2, Bn, your dot product A bar dot B bar is A1, B1 plus A2, B2 plus so on An, Bn. A1 is multiplied with B1 plus A2 is multiplied with B2 plus A3 is multiplied with B3, so on and so forth. An is multiplied by Bn. I can write, let me rewrite this notation again. Let me rewrite. How can I write? Just see, this is my, what is my vector A? For simplicity, let me say this is A. A is A1, A2, so on An. What is my vector B? My vector B is B1, comma B2, so on, let me say Bn. What is my A dot B? Otherwise, if you want, just keep as they are vectors, you can keep bars. A bar dot B bar means, according to the definition, how we are writing A1 B1 plus A2 B2 plus so on An Bn. This can be written as A1, comma A2, comma so on An into, I can write it as B1, B2, so on Bn. Can I write like this? Yes. So I have row vector and a column vector. A is my row vector. Let me say this is A1, A2, An is row vector, B1, B2, so on, Bn is column vector. A is row vector and B is, just you can write it as, isn't it? Some of you might have studied about multiplying matrices and multiplying vectors in your 11th or 12th grade. So what does this mean? This is basically means, remember, A is 1 by n matrix. What's the order of this A? How many rows? There is 1 row and n columns. And this is 1 by n matrix, means that's a vector. Basically it's a row vector. And B is column vector. What's the order? There are n rows and 1 column. What does it mean? It is a column vector. What is the rule for multiplying two matrices? Number of columns in first matrix must be equal to number of rows in second matrix. I can treat vector is also one type of matrix as they are matching. Just see, this n is matching with this n. So that certainly I can multiply this, I can multiply these two vectors, isn't it? As number of columns in first matrix is matching with the number of rows in second matrix. In this context, matrix means, as I told you, this vector can also treated as a matrix, row vector, column vector, row matrix, something like that, isn't it? I multiply them. What you are getting? A1 B1 plus A2 B2, so on, An Bn. Whenever somebody says a vector, this you must understand. Whenever, I will repeat, whenever somebody says a vector, they are typically referred to as column vector. By default, if someone says vector, you must understand it as column vector. So whenever somebody says A is a vector of size n, what do they mean? They typically mean that A is a column vector. I can say A1, A2, so on. By default it is. If they are not specifying, you must understand it is a column vector. This is just for simplicity. Whenever somebody says A is a vector, by default it's a column vector, because there is always a confusion. Is a given vector is row vector or a column vector? If nothing is explicitly told about that, you have to assume that itself it's a column vector. So what we have here is a row vector of A. Here my A is row vector and a column vector, my B is column vector. This is also written as, you can write this dot product, you can represent like this, isn't it? Because the default, if I say, let's assume I have a column vector A1, A2, so on, An. Let's assume this is my vector A. I can say A equal to A1, A2, so on, An. Because the default representation is always column vector, which is of size. Column vector means what? Size n by 1. There are n rows, 1 column, n rows and 1 column. Now, what does it A transpose? A transpose means what? A transpose means, how can I write? This column vector will be converted into row vector. I can say A1, comma, A2, comma, so on. I can write it as An. I can convert column vector into a row vector just taking an operation called transpose, and that becomes 1 cross n. This is how many rows? There is 1 row and n columns, that is 1 cross n. So going back to our previous example, what we have here literally is nothing but A transpose multiplied B, isn't it? What does it mean? This one A bar dot B bar. This is A1, A2, An. This can be, for example, my vector A is A1, A2, An. By default, vector is column vector. A is A1, A2, An, and your B is, let me assume, B is, as by default they are column vectors, B1, B2, so on, Bn. Therefore, how can I write this one? This one can be written as A transpose. Why? Because from just, yes, let me assume like this. This is my A vector, this is my B vector. A transpose, this is A transpose into B. B is column vector. And what does it all boil down to? It's boiled down to summation 1 to n. If A is, I can write it as, let me write A dot B is equal to A transpose B, isn't it? Which is equal to sigma I equal to 1 to n AI BI. Can I write like this? Why? Because A1 B1 plus A2 B2 plus so on AN BN. This is what a dot product is from pure linear algebraic perspective. Now let's go and understand geometrically what does A dot B means, because that's important. We will connect the geometry with the linear algebra, because if you don't connect it, we don't understand what a dot product means in high dimensional spaces, because we are doing all of this new algebraic exercise to understand geometry. Let's assume we live in two-dimensional space, or we have two-dimensional space. Let's assume I have a vector A. Let me assume I have a vector A and I have a vector B. This is my vector A and I have a vector B. Of course, A has two components. How many components does A is having? Two components, A1 and A2, and B also has two components, B1 and B2. When we have these two components, let me assume this one is my x1 axis, this one is my x2 axis. This is your vector A and this is your vector B, isn't it? Which one? This is vector B and this one is your vector A. This is your vector A and this is your vector B. Now what does A dot B represent geometrically? That's our question. I can say A dot B is, let me write, A dot B equal to, I can write A dot B can be written as norm A. I can say it's a norm A into norm B. Norm A means length of vector A. Norm B means length of vector B into cos theta. What is my norm A? This is length of the vector norm A. This is length of the vector norm B, isn't it? Now this is simple formula, isn't it? Let's assume the angle theta. This is the angle theta in between. Let me repeat. Let's assume the angle theta in between A and B. Length of A is, as I told you, norm A, and length of A is nothing but distance of A from the origin. This length means what? This is the origin. It's a length of A means it's a distance of A from the origin. In similar manner, length of B means it's a distance from the origin to this particular point. That's length. Simply I can say, as I told you, A dot B equal to, how can I write? I can write A dot B is equal to A1 B1 plus A2 B2. This I already discussed, which is equal to norm A into norm B cos theta. What is theta? Theta is angle between these two vectors, which means theta is nothing but, how can I write my cos theta? How can I write cos theta? I can write, instead of saying cos theta, my theta is nothing but cos inverse of A1 B1 plus A2 B2 by norm A into norm B. That's angle between. This is length of A. What is this? What is this? This is length of A, isn't it? What about this? This is length of B, isn't it? Length of A is nothing but norm A. Length of A is nothing but norm A equal to under root of A1 square plus A2 square. What about length of B? Norm B equal to under root of B1 square plus B2 square. This is simply norm. This is a distance between origin to this particular point, isn't it? If somebody gives you two vectors, you can easily find A dot B. The angle between both of them Now you can find angle between that two vectors. Now this takes us to an interesting idea. Let me assume I have two vectors here. What is the angle between these two vectors? Just see, it's a 90 degrees. Let me assume I have two vectors. Let me say instead of x, let me say this is vector A. Instead of y, let me say this is vector B. What is the angle between these two vectors? 90. Let's say I have two vectors. I have vector A and vector B. Angle between is 90 degrees. What is the angle between these two? Is 90 degrees. Here A is A1, A2. Let me say A is A1, A2. My B is B1, comma B2. What is my A dot B? A dot B is norm A into norm B into cos theta. What is my theta? Theta is 90 degrees. Cos 90 means 0. Therefore, your A dot B equals 0. If they are perpendicular, if dot product between A and B is 0, isn't it? We know that these two vectors are perpendicular to each other. Remember, this whole idea of angle between two vectors can be extended to any dimensions. It could be any dimensions. Even you can write A equal to, if there is n dimensional vector, a1, a2, so on, an, and this is a vector A. What about vector B? Let me say B equal to b1, b2, so on, I can say bn, isn't it? Here we can't visualize more than 3 dimensions, but with the help of linear algebra, you can formulate these formulas. I can write theta A dot B equal to norm A dot B equal to norm A into norm B cos theta, isn't it? Your cos theta equal to, how can I write? Your cos theta equal to, I can write it as, otherwise I can write theta equal to cos inverse of sigma I equal to 1 to n ai into bi by norm A into norm B, isn't it? Can I write like this? This is for n dimensional space, isn't it? For simplicity, here we are taking numbers. This is 4 comma 2. This is minus 1 comma 2. Just multiply them. X transpose y. What is my x transpose y? X transpose means as it column vector, I must write it as row vector. What is my y? Minus 1, 2. Just according to multiplication, 4 into minus 1, minus 4, plus 2 into 2, 4, minus 4 plus 4, 0. That's what it says. As they are perpendicular to each other, your cross product is 0. It's simple and straightforward discussion. What we learned in 2D, we are just extending to n-dimensional space. Whatever I learned in 2D, just extend to ND. What does A bar dot A bar? Let me say this is a vector A. How can I write vector A with how many components? Let me say A1, A2, so on. I have n components. This, let me say this is D. What is your A dot A? A dot A means I can write A1 into A1. If you want, you can write it as with bar notation. A1 into A1 plus A2 into A2. According to the dot product definition, I can write it as AN into AN. Therefore, it can be written as A1 square plus A2 square plus so on AN square. That is essentially norm A whole square, isn't it? This is this distance D. This distance D means what? The distance D means norm A. Norm A means norm A equal to A1 square plus A2 square plus AN square. Norm A means under root of A1 square plus A2 square plus so on. I can write it as AN square. Just go through this lecture. This lecture is simple and straightforward. If you have any difficulty, just keep a comment. Thank you very much.